Hey, geometry, today we're going to get into 1.4, the addition postulates. So it's actually basically just addition in space a little bit. So we'll start out with segments. So if you are dealing with segments, if 3 points, A, B, and C, are collinear, they're all on a line, and B is between A and C, then we know that from A to B plus the distance from B to C will equal the distance from A to C. And let me draw a picture to show that. So we've got these points all collinear, A, B, C, and maybe they don't have to be a midpoint. I drew those kind of evenly apart, but they don't necessarily have to be. A, B, C, if A to B is 5 and B to C is, say, 4, just to make it different, if that's the measure of that distance, then we know that from A to C will be 5 plus 4, which is 9. All right, so that straight line just kind of adds up. And that's a pretty intuitive concept, I think. All right, so that's the segment addition postulate, and we can apply that in a number of ways. So given that BT is 36, so we know that this whole distance here is 36. Let's see, given that BT is 36, let me see, we're supposed to add to this one, hold on. Sorry about that. So there were some missing pieces on this. This segment was supposed to be labeled as 8x minus 14, and this one is 2x, so that we can actually solve some things here using some algebra with this. So given that BT is 36, that full length is 36, we can actually solve for x and set up a relationship here. So we know that this length from B to A, so 8x minus 14, plus the distance from A to T, and so actually I'll even write this up here, BA plus AT is equal to BT. Right, that's our segment addition postulate, but then I'm actually going to plug in those measurements. So 8x minus 14 is what BA is, AT is 2x, and then the full distance we're given is 36. So we can set up and solve that for x. So we can combine those like terms right off the bat and get that that's going to be 10x minus 14 is equal to 36. Add the 14 to both sides. Canceling, 10x is 50, sorry, 10x is 50, and so then we divide by 10 and get x is 5. That's not the answer to the question. Ultimately, what they want us to find is the measure of BA and AT. And so we can plug that x back into one of these two to figure this out. Probably the easiest one to plug into is the 2x. So AT, we know is 2x. Well, if we plug in x is 5, that's 2 times 5, which is 10. We could do something similar with BA. We could plug in x and see what we get, and maybe I'll double check that in a second. But we can also know, all right, well, if this is 10, if that distance is 10 out of that 36, so this other side has to be 26. So 26 plus 10 gives us 36. So we can know that AB, sorry, not AB, AT. Nope, I still said it wrong. Sorry, BA. I'm gonna stick with what I had up here. I looked at the wrong picture. We know that BA should end up being 26, but we also could have done it by plugging it in. We could have done 8 times 5 minus 14, got 40 minus 14, and get 26 that way. So that is finding those segments there. All right, this next one, so let's see, hopefully it's all here. We got MA is 5x minus 3, AN is 30, and then MN is supposed to be given. Sorry, this should be 8x plus 6. That should be a given. I didn't produce that. Otherwise, if that wasn't given, all you could say, you can figure out what MN is by just adding these two together, and it would be 5x minus 30 minus 3 plus 30, which would be essentially 5x plus 27. But we do have this, all right, so we can actually set up and solve and figure out what x is. So we know that MA from our segment addition postulate plus AN should be equal to MN, which I'll go ahead and put that on there. MN is 8x plus 6. So we can write this all out algebraically. 5x minus 3, so that's MA, plus 30 equals 8x plus 6. We can combine the negative 3 and 30 to get that 5x plus 27 I mentioned a moment ago is the same thing as 8x plus 6. Start solving. I'm going to bring my x's to the right to keep things positive, minus 5x. You don't have to do it that way, but it saves a step. Minus 5x on both sides, that'll cancel that, and I'll go ahead and at the same time I'll get rid of the 6 on this side since I'm not going to want it here, and subtract that from both sides. So 27 minus 6 is 21 equals 8 minus 5 is 3x. Divide by 3, divide by 3, x is 7. And that's our goal, and you can turn that around. X is 7. So that's that one. All right, down here at the bottom, if you're great with this, you can probably skip the rest of this video. I'm just going to go through this section and then we'll get on to the back. But just solving equations. Remember, when you're solving equations from algebra, you are trying to figure out, solve the mystery of what makes these two sides balanced. And so we need to kind of unwrap that x, and when you're unwrapping something, you kind of do it in the reverse order. You take off kind of the outer layer first. So we actually solve this in the reverse order of operations. This 2 gets multiplied first, and then the 1 gets added. So to kind of unravel what that x is, the first thing we'll do is we'll peel off that 1. And so we realize in an equality, if we subtract 1 from both sides, those two quantities are still equal. So we know that if we subtract 1 here, that'll go away, and we know that 2x is equal to 8. And then with multiplication, if this is getting doubled, well, if I know if I divide this side and divide this side, if I divide both sides by 2, those quantities are still equal. So that cancels out, and so we have x is 4 for solving an equation like that. This one, step 1 would be to combine like terms. So we have a couple of different x's. We want to isolate the variable in these types of equations. So we really just want one variable, so we try and get them together. So we can combine 2x and negative 5x's. Those combine to be, so if you add those together, you get negative 3x. And then we have still plus 1 on this left side and 9 on the right side. So we can peel off that 1, and that's going to leave us with negative 3x is equal to positive 8. And then we can divide by negative 3 on both sides. You could divide by 3 and then multiply by negative 1, but doing it all at once. Divide by negative 3, we get x is negative 8/3 would be acceptable. You could write that as negative 2.6 repeating as well, but negative 8/3 is a good way of writing that. All right, down here, we got the x's on both sides. We still want to get them on the same side, so I realized that, all right, I could either subtract 2x from both sides, and that would get rid of it over here, or I can add 3x over here. I'm going to prefer to add the 3x because I know that it's going to leave my x's positive. So we can add 3x to both sides. That's going to go away. And so I'm going to end up with 5x on my left side. At the same time, I like to do this when they're set up like this. I'm going to go ahead, and I know I want to get that 1 away. I'm going to subtract 1 from both sides. So that's going to be gone, and we're going to be left with 5x is 10. And then at this point, I can divide both sides by 5, and x is 2. And then the biggest, ugliest one here, we got to get all of our x's together. So maybe I'd start out by combining like terms on each side. So I'm going to do like a separate symbol for these. So I'm going to combine the underlined 2x and 3x to get 5x. I'm going to combine the squiggle lined 1 and 4. Those add together to get 5. And then on the right side, we can combine those as well. So I'll do dotted there. We're going to combine the 19 and the negative 5. So 19 minus 5 is 14 plus 3x. Now we got something looking pretty similar to this. I'm going to subtract 3x from both sides because I know that'll leave the sides still balanced, still equal. I'm going to subtract the 5 from both sides. I'm bringing x's to the left. I want to get everything else to the right side. So that cancels, and so I ultimately have 2x is 14 minus 5, which is 9, divided by 2, x is 9/2 is good. Sorry, not 9/2, or it is 9/2, not 9/5. 9/2 or 4.5 would be acceptable answers for that. So there's a little algebra review of solving for you. If you have questions on this stuff, get on top of this soon because we're going to be doing these all year.